the surface area of the section of the cylinder x square plus y square equal to a square made by plane x plus y plus z equal to a. So before starting with the solution, let's recall the formula first for the surface area. Alright, this is your x, y and z axis, and let this be the surface z equal to f of xy, that is your S. And this is the region R, that is the orthogonal projection of this surface S, right, on the xy plane. That is given by this region R, that is phi of xy equal to 0. For xy plane, z is 0. So, phi of xy is 0 over here. Let me consider a small element in the xy plane. This is parallel to x-axis and this is parallel to y-axis, right? So I'm considering this small area, delta x, delta y, and this is having its generator parallel to the z-axis, touching the surface S. Like this, right? And this is the element of area delta S. Fine, right? And let's say this Pn, this is your point P, and let's say this Pn be a normal to the surface S, making angle alpha with x-axis, beta with y-axis and gamma with z-axis. So this is making angle gamma with z-axis, this normal Pn, making angle gamma with z-axis, right? So this is just the description. And then the total surface area, this complete surface area is equal to taking the double integration over this region R, right? And this is a very simple formula. Just take the square root of, this is your z, and which is a function of xy. So differentiating z with respect to x first and taking the square, plus differentiating z with respect to y, again taking the square, plus 1, right? This is the formula, and this is dx dy, right? Okay, now moving on to the solution. Find the surface area of the section of the cylinder. Cylinder is given to us, that is x square plus y square equal to a square, and the plane x plus y plus z equal to a. Just take the value of z from the plane, that is a minus x minus y, and now calculating curly z over curly x, which means differentiating z with respect to x, we get negative 1, and curly z over curly y again is negative 1, and the required surface area. What is the region given to us? That is x square plus y square equal to a square. This is the region given to us. X square plus y square is equal to a square, right? Okay, so writing the formula for the surface area, which is double integration over this region R, curly z over curly x square plus curly z over curly y square plus 1, and taking the square root, complete square root, and then dx dy. Now it is your choice whether you want to take the limits of x as constants or the limits of y as constant. This is your choice with the help of the given region. First of all, let's understand that the plane is given to us, that is x plus y plus z equal to a. Suppose this is the distance a on the x-axis, and similarly this is also the distance a on the y-axis, and this is distance a on the z-axis from the origin. This is your plane, x plus y plus z is equal to a. And then the cylinder is also given to us having the radius a. On the xy plane, we are having this section of the cylinder as x square plus y square is equal to a square. So if you notice over here, by symmetry, if I take the surface area in the positive octant, then by symmetry we get the required surface area as 4 times the surface area taken in the positive octant. So the required surface area becomes 4 times the surface area taken into the positive octant. Now talking about the limits. Now if you want your limits of x to be constant, then limits of x are from 0, this origin 0 to this a, right? And the limits of y is from 0 to, just take the value of y from here, that is y is equal to a square minus x square square root. So this is a square minus x square square root. If you want your limits of x to be constant, then the limits of y should be in the form of x, right? So you can get the limits of y from this equation. It's okay, fine? Alright. So now calculating the surface area. So this is 4 times the double integration over the region R, and because the limits of x are constant, so writing 0 to a, the limits for x, and that should be written, this is the outer integral, that is dx should be written on the right hand side, and dy should be for the innermost integral, and the limits of y are from 0 to square root of a square minus x square. And then we are having here square root of, yes, what is curly z over curly x? That is negative 1, so this is 1. Minus 1 whole square is 1. So here also I get 1 plus 1, that is 1 plus 1 plus 1, which is square root of 3. So this is 4 square root 3 from 0 to a. Integrating 1 with respect to y is y from 0 to a square minus x square under the root, and then dx. So putting the upper limit, we get square root of a square minus x square minus the lower limit, that is 0, you get 0 here, 0 to a integration, and this is dx. Now integrating this with respect to x, what do you get? There is a formula, that is, this is, yes, x over 2 square root of a square minus x square plus a square over 2 sine inverse x over a. This is the formula for this integration from 0 to a. So this is 4 root 3. Putting a over here we get 0. Putting a over here we get a square by 2. Sine inverse 1 is, yes, pi by 2. Minus, putting 0 you get 0. Here also you get 0. So I'm having, okay, this is 4 cancelled out. So this is pi a square under the root 3. Right, so this is root 3 pi a square as the required answer. Thank you.